And then welcome to video 3 of the functions and graph topics. Today we're going to look at inverse functions. Okay, so a couple of things we need to be able to do after this video. Being able to understand the meaning of what an inverse function is, being able to identify the inverse of a given function, understand the condition for composite functions to be inverses of each other, and lastly, being able to draw the graphs of inverse functions when given a graph of the original. Okay, so inverse function, first of all, we have worked with inverses quite a lot over our time in maths, even going right the way back to primary school, knowing that subtraction is an inverse of addition, knowing that multiplication is an inverse of division. These are all inverses. Okay, an inverse function, okay, if we use our function notation here, the function f takes you from a group of x's to a related group of a set of numbers, set of things called your f of x. Okay, your inverse function is the one that takes you back the way. Okay, the inverse function, and we do f with a wee -1 there, which can look a little bit like differentiation, but you just need to be careful and make sure you're reading it thoroughly. Okay, your inverse function will take these things back to where they started. Okay, so your inverse function is essentially the opposite function. Okay, so f of x here, got a quick example. If f of x is 3x and g of x is x over 3, find the value f of g of x. Okay, so f of g of x, we know really means f of x over 3, which means x over 3 is getting substituted into x. So it's 3 multiplied by x over 3, and all that's going to happen there is your 3 cancels out and leaves you with x's. Okay, now f of g of x here means that we are doing a function f. We're starting with our x's, we're applying a function f, and then another function's coming along. In this case, well, actually, I've done it the other way around. We've done g of x, and then we've done f going backwards, but they've ended up back at the same place. They've ended up back at your x's here. Okay, so in this case, f and g are essentially cancelling each other out and leaving you with that x you started with. So in this case, f and g are inverses of each other. Okay, they are the opposite functions. You can see that. It's a nice, simple one. One is multiplied by 3, one's divided by 3. They are the opposite things. Okay, now the big thing here is being able to find the inverse function of a given function. And to do that, we are essentially going to change the subject. Okay, when you are working with an inverse, when you're working with a function, you start with your x's and you end up with your f of x's. The inverse function does the opposite. It starts with your f of x, it ends up with your x's. Okay, now I'm not a massive fan of the brackets kicking about of the f of x, so I'm going to just call this y equals x plus 2, and then I'm simply going to change the subject to x. Okay, so change the subject to x, take away 2, so y minus 2 is equal to x. Okay, and you can see how that's turned around to give you the opposite, to give you the x's rather than the f of x's. The only thing we need to do now is rewrite this. Okay, rewrite this as its own function, as specifically the inverse function. And that is the inverse of x. Okay, the inverse of f, sorry, f inverse of x is equal to y minus 2. Okay, but because it's its own function, it's going to be in terms of x's, and it's just x minus 2. Okay, so f inverse of x is equal to x minus 2. Okay, same here. First thing I'm going to do is I'm going to rewrite it just with a y, just to save those brackets confusion matters. And then I'm going to change the subject to x. So first things first, add 5 to both sides. And then divide by the 3. So y plus 5 over 3 is equal to x. Now that's your work done. The only thing you need to do is rewrite it as its own inverse function. Okay, so we're going to do the inverse of g here. And this is what it needs to look like. It's not going to be y, it's going to be x plus 5 divided by 3. Okay, that is your inverse function. Okay, C here, give it a try. Excuse me, sorry. Okay, give it a try there. Pause the video and I'll do it in a second. Okay, so first things first here, I'm going to just turn that f of x into a y just to make it nice and easy. 2x plus 1 cubed, and then I'm off to change the subject. Okay, so inside the brackets will need to be left to last, so that cube needs to go first. So we're talking about the cubed root of y is equal to 2x plus 1. So the cubed root of y minus 1 is equal to 2x. And then the cubed root of y minus 1 all divided by 2 is equal to x. Okay, I'm just going to make that cube root a bit clearer. Okay, so that's my work done, and now I just need to rewrite it as its own function. Okay, so the inverse function of x here is equal to the cubed root of x. Remember, you're swapping that y out, all minus 1 all divided by 2. Okay, now your actual is just changing subject, nothing to worry about. Yeah. Okay, now last things last thing we're going to look at is just quickly look at the graphs. Okay, we've got two functions here. Okay, I'm going to call this f of x. Okay, and we're going to look at a couple of points on it. Okay, now this one here, let's call it 0y or 0y1, and let's look at another point, x. In fact, I'm going to call it ab just. Excuse me, a wee second, sorry. I'm just going to call it 0a, and I'll call another point bc. Okay, now because your inverse function essentially is swapping these around, like x gives you your y, and then for the inverse function, your y gives you your x. So you start with your y, turn it into the x value. Okay, essentially for the inverse function, the graph is just going to be the other way around. So instead of being 0a, it's going to be a0. Okay, instead of being bc, it's going to be cb, because your inverse function goes the other direction. Okay, now what actually happens here? Yeah, so what's actually happening here is, for you and you're graphing an inverse function, f of minus 1 of x, it provides a reflection. Okay, it reflects in this line y equals x. Okay, the inverse is a perfect reflection in that line, the line going up at 45 degrees through the diagonal. Okay, so if you're given an f of x and you need to replicate it, or you need to, excuse me, sorry, you need to sketch of inverse, you just need to put your y equals x line in, and then sketch it over as a reflection in that line. Okay, so for a couple of examples here, I'm just using Desmos, which is a beautiful website if you want to use it to find out some graphs of anything. I'm just going to look at a couple of inverses. Okay, so you can see the kind of reddish line there is the line y equals x. Okay, I'm going to put on the graph of x plus 2. Okay, so we know that x plus 2 is going to be parallel to y equals x there is there. Okay, but you can also see x minus 2, so looking at plus 2 and minus 2 being the inverse of each other is perfectly symmetrical along that red line. Okay, so look at another 2. 2x plus 1 is going to look like that. The inverse of 2x plus 1 is take the 1 then divide by 2, so x minus 1 divided by 2. Okay, you can see there again is perfectly symmetrical around that diagonal line. Okay, and last pair I'm going to show you is x cubed, looks like this. The cubed root of x looks like that. Okay, so you can see there how your inverse is totally symmetrical around that line there, and especially around here if you're asking, so you just need to be careful of that. Okay, so all of them together, just finish off on that, just to show you how pretty you can make these patterns look just by using inverses. Okay, so that's the kind of whole story there. 4 things you need to be able to do: being able to understand the meaning of an inverse function, the fact that they're opposites, being able to find the inverse function just by changing the subject and being careful how you write it, the condition of composite functions to be inverses, and they do like to chuck that in as like a wee 1 marker at the end of a question, is the fact that if you have composite functions giving you x, that means they're cancelling each other out, which means they're inverses. And the last one, which you'll get some practice on in classes, is being able to draw the graphs of inverse function using that line of symmetry y equals x. Okay, thanks for your time.